How are you, my friends? This is review questions number 2 on algebra of matrices, inverses, and determinants. Question number 1, given the matrices A and B, each one is 2 by 2, such that capital T, the matrix, is equal to 2a squared minus 3b plus 10i, where I is the 2 by 2 identity matrix. Now the question, find the sum of the entries on the main diagonal of the matrix T. So first we have to find the matrix T, then we add the entries on the main diagonal. So this is easy. Just make sure that you understand this one. A squared means A times A. We don't square each number separate. That's completely wrong. If you write 4, 9, 25, and 1, that's completely wrong. A squared means A times A. So multiply A times A, multiply the row by the column here. 2 times 2 is 4, minus 3 times 5, minus 15 plus 4 is minus 11, and so on. Now, 2a squared, this is a squared. 2a squared multiplied by the scalar, 2 times every entry inside, minus 3 times the b here, plus 10 times the I. So capital T becomes, if you simplify all this, it will be minus 18, check the numbers please, minus 33, 39, minus 21. The question says, find the sum on the main diagonal of the entries here, minus 18, minus 21, the answer is minus 39. Question number 2 is nice question. Given the three matrices, capital X is M minus 3, 1 minus 2. Capital Y is 3 by 3. So capital X is 2 by 2. Capital Z is 4 by 4. Find the value of M. We need this value here. If the sum of the determinants of the three matrices is 100. So what do we have to find? M is what we need. The determinant of the X plus the determinant of the Y plus determinant of the Z is equal 100. So for sure we have to find the determinant of each matrix alone. Determinant of the X, this is 2 by 2, easy. M times minus 2, the main diagonal, minus 3 times the 1. So it will be minus 2m plus 3. Leave it. Let's write the matrix Y in triangular form. So this is 3, 0, 0, 5. Let's make this number here, the 10. See this 10 here? Let's make it 0. So multiply minus 2 times row 2. We add to row 3. We get 0, 0, 0. So the determinant of the Y, we multiply the entries on the main diagonal. 3 times 5 times 3, which is 45. If you have all zeros under the main diagonal. Now let's continue. Now the determinant of the Z, the third matrix, 4 by 4, it's already, all we have to do a little change here. You see this minus 9? Multiply by 3 to make it triangular form. Then you multiply 2 times 3 times 3 times 2, it will be 36. Now from the given we have the sum of the three determinants is equal 100. So minus 2m plus 3 plus 45 plus 36 is equal 100. Minus 2m is equal 16. Add this, subtract on the other side, m will be minus 8. Question number 3 also is simple. We have capital X minus 2, 3, 6, 0. Capital M minus 7, 3, 2. This is 1 row, 3 columns. And this is capital A, 3 rows, 2 columns. 0, 1, 1 minus 2 minus 4, 5. Find the sum of all the entries of the matrix max. So we have to multiply M times A times X. So we have to check the dimensions. All right, so we need max, so M, this is M here. 1 by 3, A, 3 by 2. See, this is 3 rows, 2 columns. So these two numbers should be the same, so we can multiply M times A first. then the answer will be the dimension 1 by 2. And this is 2 by 2. Also, we can multiply the product here by the x. So the whole answer, the dimension should be 1 by 2. So let's multiply first MA. So this is M here. See, this is M in the middle here times the A. Row by the column. Row, see, this is all row by the column. So minus 7 times 0, 3 times 1, 2 times minus 4. So this would be minus 5. Then this row multiplied by this column, minus 7 times 1, 3 times minus 2, 2 times 5. When you add, you get minus 3. So this is MA. MA times the X. X is the first one here. So row by the column, you get minus 8, minus 15. This is the matrix max. The sum of all entries, minus 8 plus minus 15 minus 23. Question number 4 is a nice question. We have matrix E and F, 2 by 2 each one. If E times D is equal to F, E is given, F is given, we have to look for capital D, which is a matrix. Find the sum of all entries on row 2 of the matrix D. So we have to find the D. Remember here, don't do big mistake here. You cannot divide matrices. E times D is equal to F. You have to work with inverses. This is the given here. E times D is equal to F. Let's multiply by the inverse of E from the left. So we can put here E inverse times the E times the D is equal E inverse times the F. See, from the left side, we put E inverse. Now we know E inverse times the E is the I, the identity. And the identity times the D is D. So now D on the left here equals E inverse times F. It should be in this sequence, in this order. E inverse times F. We cannot write F E inverse. That will be wrong. So E inverse, F is there. You see, F is there. 6 minus 5, 0, 3. So this is F. Now I have to find the inverse of the E. This is E, 7, 2, 4, 1. And remember, this is the formula, 2 by 2 inverse formula. You know that. So we find the inverse of the E. 1 over 7 minus 8. Interchange the main diagonal. 1, 7, multiply with minus on the other diagonal. So we get now minus 1, 2, 4 minus 7. Remember, there is a minus 1 here. So you have to multiply inside as a scalar. Now you multiply these matrices. Remember, row by column, row by column, row by column, row by column, row by column. You get minus 6, minus 1, 24, 1. What do we need? This is D. Remember, this is matrix D. The sum of the entries on row 2, 24 and 1, you add, you get 25. Question number 5 is a straightforward question. Use an inverse matrix to solve the linear system. We have 3x minus 4y is equal to 26, minus 5x plus 6y is equal to minus 40. We need to find the point of intersection xy, but we have to use this method, the inverse. So we can write the matrix equation here, 3 minus 5. Make sure all the x will line up, all the y will line up, minus 4 and 6, times xy is equal to 26 minus 24. So this is ax is equal to b. We know in this method, using the inverse, ax is equal to b, x will be a inverse b. We cannot divide, remember, matrices. So x will be, which is x and y, will be a inverse times b. So we have to find the inverse of this a. So to find the inverse of A, use the 2 by 2 inverse formula, 1 over AD minus BC. Switch the main diagonal and multiply with minus the other diagonal. So if we have, this is A, so A inverse will be 1 over 18 minus 20, 6, 4, 5, 3. Now, you multiply this scalar 1 over minus 2 inside, so you get this is the inverse. Now we have to find the solution. it will be the inverse of A times the B. B is 26 minus 40. So we multiply the first row, first column, minus 3 times 26 plus minus 2 times minus 40. And then down here, row 2 with column 1, minus 5 over 2 times 26 plus minus 3 over 2 times minus 40. So this will be minus 78 plus 80, which is 2, minus 65 plus 60, it will be minus 5. So x will be 2 and y will be minus 5. The solution will be 2 and minus 5. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.